This is 4-port converter, which consists of PV source, a DC voltage source. Here the DC voltage source is of 48 volt. Battery is of 24 volt, and load of 32 ohms. So this is port 1 PV panel. The panel voltage is around 24. DC voltage source 48, say 2 ports. Battery is third port, 24 volt, and load is 1 port. So totally 4 ports are there. In PV source, the voltage is 24 volt and current is around 7.69 amps. So totally the power is around 183 watts for one panel. Here 12 panels are connected in parallel. So the power is around 2000 watts we will get. And irradiation initially it is around 1000. After 1 second it is reduced to 400. And after 0.7 second it is going to 0. So initially 1000, after 0.7 seconds it is going to 0. That is the irradiation levels. So initially the PV will generate higher power. After 0.7 seconds it is PV will not generate any power here. At the time this DC voltage source plus battery will provide the supply. Here if you see the voltage is around 180 volt. After 0.7 seconds, the battery is providing the supply. So there is slight oscillation in here. This is due to the variation in the duty ratio and also due to the variation in the battery voltage. Until 0.7 seconds, the PV plus DC voltage source is providing the supply. This is the power of PV plus DC voltage source. Here the first one is power of DC source. It is 0 initially. And the power of PV panel is around 2500 watts we are getting. And after 0.7 seconds, the PV is not generating any power. So the power reaches 0. And the DC source is providing the power of 1000 watts. And this is the battery supply. That is state of charge of the battery, voltage and current. Initially the battery was charging, so the state of charge is increasing. After 0.7 seconds, the battery was discharging, so the state of charge starts to decrease. Similarly, the current also initially it is negative because the current is flowing in the opposite direction towards the battery. And after 0.7 seconds, it is going to positive. That means the current is going to from the battery going to the load. First one is battery power. Initially, the battery is consuming the power as it is charging. So it is around 1200 watts. And after 0.7 seconds, it is going around 500 watts. It is discharging. That means it is providing the supply to the load. It is around 500 watts. Similarly, the input power. Input power is around 2500 watts initially due to the power generation from PV and also from DC voltage source. And after 0.7 seconds, only the DC voltage source is providing the supply as PV is not available. So here we are getting 1000 watts. And the load power is around 1200 watts. Initially it is around 1200. After 0.7 seconds, there is slight oscillations, but it is still maintained at 1200 watts. So the load is uh, consuming constant power irrespective of batteries charging or discharging or PV is available or not available. So these are the results we have to check. Initially, when the PV is available, the battery is charging and also the load is consuming of 1200 watts. And when the PV is not available, at the time the DC voltage source plus battery is providing the supply to the load. The load is consuming constant power throughout the time period. And this is the efficiency curve. Okay, initially, the efficiency is around 87%. When the battery is discharging, it is reduced between 70 to 85%. It is oscillating between 70 to 85%. So this is 4-port converter in which 2 ports are sources. That is, one port is PV and one port is DC voltage source. And the third port is of battery. When PV is available, battery is getting the charge from the PV and DC voltage source. When PV is not available, the battery will provide the energy to the load, which is nothing but fourth port. This is a 4-port converter with battery energy storage system and renewable energy sources.